Okay, so we're doing notes on congruent triangles. So we're given two triangles that are the same. Okay, now technically, right, these are two different triangles. This is triangle ABC and triangle MNO. So once again, this is triangle ABC, and we're making the claim that they are congruent. Okay, the congruent symbol is an equal sign with a little squiggle mark on top. Okay, that little squiggle mark, when it's by itself, that means that two things are similar. That means that two things, okay, this is the symbol for this is the equal sign. Okay, this is the symbol for similar. Okay, and things that are similar are the same shape. Okay, so if you're telling me two things are similar, that means all the angles are the same, that it looks the same, right? But they might be different sizes, like a small one and a big one, like a small square and a big square. They're similar, right? They're just different sizes. And so by using like an equal sign, that means things are the same size. Okay. So things can be the same size but different shapes, and things can be the same shape but different size, but put that together and they're called congruent. Okay. So, whoops, congruent. Okay. That means same shape and size. And my writing is atrocious this morning. What's going on? So the same shape and same size. So we have triangle ABC. Now watch how I label this. This is one of the most important things you're going to see in this section, okay, is being able to label stuff, which sounds kind of silly, like, wow, you labeled it. That sounds pretty easy, like one of the easiest things you can do in this book, on this website, in geometry in general, okay? But it's very important. You got to be careful how you label it. You see how I went A, B, C, okay? And it's in this order, like A and C, M and O are the same. So that those pieces are the same and those pieces are the same. So it's in like the right order. If I label a triangle like ABC and I'm saying it's congruent, I have to label it M and O. If I switch up the order than what this order is, then it's not a correct statement. Then it's actually wrong. Okay, because you're making the claim that the parts are in a specific order. So however you write the first one, the second one has to be written in the same order. Okay, you have to kind of follow the A, B, C, M, N, O. All right, hopefully that kind of makes some sense. All right, so they labeled theirs in the video notes like this. Okay, that meant that this one and this one, this one and this one, right, from B to C, N to O, those are also that they're the same side lengths. Okay, and then lastly, we're going to claim this bottom one is the same side length too. Okay, so that is claiming that this piece and this piece are congruent, this piece and this piece are congruent, this piece and this piece are congruent. And what also comes up is they label it like this. They say O and C are the same angle measurement. Maybe it's 40, so that's got to be 40 or whatever. And then they say the second angles that are the same would be these angles. Okay, the little two lines here and the little two lines there. And then the third angle here, they're claiming to be the same as well. So since everything is the same, it's the same shape and the same size, we can claim that they are congruent. Okay, and look at this. You see how like C has the little one mark here? C here is the last letter, O is the last letter. You see how, let's go to A. A's got the little two marks here. M has two marks there. So A and M, they're in the same location here. Even B's got the three marks, N has the three marks. It's in the middle, it's in the middle. You look at, let's look at AB. You saw AB in this order, goes from this here to this here. MN goes from that to there. It's like everything matches up perfectly, just the letters have been changed because it's a different shape. Sorry, it's a different drawing, but they're the same size, the same shape, the same order. Everything is the same, okay? All right. So let's go ahead and back to the presentation.
two triangles are congruent because corresponding sides and angles are congruent. When we identify congruent triangles, it is important to know where the corresponding angles and sides are. In this case, triangle ABC is congruent to triangle MNO. And the order in which we list these vertices is important. Vertex A corresponds to vertex M, vertex B corresponds to vertex N, and vertex C corresponds to vertex O. So the order in which we list these triangles is important. When referring to corresponding parts of triangles, it is called corresponding parts of congruent triangles are congruent, or for short it's CPCTC. Now let's talk about the different ways to prove
That CPT, wait, congruent parts, congruent triangles are congruent. CPCTC. That's more commonly used if we were working with proofs. We're kind of skipping over that for right now. Proofs are where you usually have a little bit of information and you're trying to prove certain things are true or certain things exist. And so a lot of times if you're like, oh, this is this then. It's like, where's your evidence? Oh, well, CPCTC. Congruent parts, congruent triangles are congruent. It's kind of like, well, yeah, this is the same, that's the same, therefore the missing information has to be the same too. It's kind of like it's very common language when you're working with proofs and you're trying to prove something with evidence that this piece equals to that piece and similar type questions. So I'm not really going to require you guys use that, okay, but that knowledge is kind of being in the background, okay, that if you have missing information for one triangle and you know they're actually the same, they're congruent, you can just fill it in, okay, because they're the same. And the mathematical term is congruent parts of congruent triangles are congruent, CPCTC, because it's such a long statement, okay?
that two triangles are congruent. The first is the side-side-side postulate, often referred to SSS postulate. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So
Okay, so you guys are so lucky. Usually every single school year when we do this kind of stuff, I have everybody sing a song. Now, for the sake of your well-being and mental health, I'm not going to embarrass you guys in front of your families or whoever might be around you during these lessons and stuff in your house, because usually in class we do this about 10 times until I get everybody to sing along with me. But there's a little song we sing with this that my teacher in high school taught me back in the summer of 1996, because I did geometry over summer school to try to jump ahead in my mathematics career in high school. And I still remember this, Mrs. Hill, 1996, Laguna Creek High School, Sacramento, California. Side, 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 angle, side, angle, side, angle, 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 side. So that was a song that we had to sing in summer school over and over and over again. And any year I've taught geometry, which has been, I think, 3 years in my teaching career, I've always made kids sing it. So whether you agree with being at home learning or not, I'm not going to have you guys sing it. However, I am going to have you guys do this right now. Can you guys please, in the chat, just type side, 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 SSS. Go SSS, side, side, side. If everyone can type that in the chat while I jot down some notes, that would be awesome, okay? That'd be so much better than singing it, right? So I know you guys are paying attention. Awesome. So when you have three triangles and all the sides are the same, when you have two triangles or more and all the sides are the same for each one, that means that they're the same triangle, that the angles are the same too, right? That's what CPCTC does. If all three triangles, all three sides of a triangle are the same, and there's this rule that I'm teaching you right now that says all three sides of this are the same, and it's called side, side, side. That means all the angles have to be the same too because of CPCTC. Congruent parts, congruent triangles are congruent. Thank you guys for throwing that in the chat. Let me show you guys what that looks like on paper. Okay. All right. So if you're given these two drawings, okay, and they're telling you that like this side, this side, this side, this side, this side, and that side, okay, I'm going to label it the same. A, B, C, M, N, O. So the fact that you have three sides of a triangle that are the same size of another triangle, and it's in the same order, okay, then you can say the two triangles are congruent. Okay. What's so special about that is because you're making the claim that they're congruent, that means the angles are the same too. Even though there's no information about the angles right now, okay, there's zero information about the angles right now, we can still make the claim that they're congruent because of the side, side, side rule. Okay. Hopefully that kind of makes some sense to you guys. I'll give you guys another about 20 seconds to copy that down, and then we'll move back to the video and kind of see what the other ones are. Okay. Like I kind of sang it out loud earlier. There's a few of them. Okay. But this one's kind of like the easiest one, but it does get a little bit more trickier after that, and we'll go through those examples here in a moment. Mrs. Hill. She also told us the joke, what do you call a cow with no legs? Ground beef. Oh, Mrs. Hill. All right. I'm gonna pause it. I'm gonna mute myself, and let's go back to the video.
If we know those two sides are congruent, those two sides are congruent, and those two sides are congruent, we know that these two triangles are congruent. The next postulate is the side angle side postulate, or SAS postulate.
All right, so the side, angle, side. So if you guys can put SAS for side, angle, side. Okay. Did I put a cat? That's fine. But side, angle, side, SAS. Okay. That is the next postulate. Okay. The next rule that we're learning. So side, angle, side. So what you should notice in this postulate, okay, in this rule that we're learning right now, that we see right now, is that you have side and side with an angle in the middle. Okay, so it's really important that you notice this. Okay, it's not just side, side, angle, or angle, side, side. It's literally angle is written in the middle between these two sides. So there's a few ways you can see this, but if you have two sides and the angle in the middle of them, okay, if those three things are considered congruent between two triangles, well, just like this one, the rest of the pieces of those triangles are also the same because they're congruent. Okay, so I'm going to keep using these letters, even though the notes in the video are using something a little bit different. I'm just going to keep using those letters so that we have some consistency with our notes. Okay, so if once again we have A, B, C, and then we have M, N, O, and we have two sides with an angle in between them. So I'm going to go ahead and just use these ones right here because they're right there. Okay, but these sides are the same and those sides are the same lengths. If that's true, that is not enough evidence to say they're congruent. Two things must exist. Okay, like I said, yeah. So either this third piece over here has to be the same. That would be side, side, side. But if the angle in between them is the same, side, angle, side, okay, side, angle, side, angle, side, then they are congruent just with this information right here. And you notice I keep writing it in this order. Okay, I could actually change up the order of these letters, but I have to follow the same vertex like rotation, right? If I went ABC, ABC. If I went ACB, I should go MON. Okay, whatever order I write these in, these have to be in the same order. You just can't mix things up. If you mix things up, it's actually considered wrong. All right. So let's kind of finish this, what he's going to talk about with the side angle side. I'm assuming he should say the same words, right, that I use as far as the angle has to be between them. Okay. If not, it might cause some funny stuff. So let's take a look at how they phrase things.
This tells us that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. If we know that this side is congruent to this side, and this side is congruent to this side, in order to satisfy the side angle side postulate, the congruent angles must be the angles that are between or included between the two congruent sides. So the congruent angle would have to be here in order to satisfy the side angle side postulate. Now we're guaranteed that these two triangles are congruent. The next postulate is the angle side angle postulate.
All right, so let's do the same thing we did last time. We're going to pause for a second. He said side angle side. I'm sorry, angle side angle. That is the angle side angle. So you can assume it's kind of like the same thing as it's written. Okay, so can you guys please put ASA or ASA and or angle side angle. Okay, that's going to be the same thing as before. Okay, it's written in a very specific way. It's not written by accident. It's not written just whatever. They're writing it in a very specific way to show you guys, okay, that the side has to be between the two angles. Okay, so angle, side, angle. I'm going to draw my two triangles. Whoops. Let's give these ones a little bit more space than the last ones. Okay, so I got two triangles. And because we're talking about the angle side angle, let's label it the same. ABC, MNO. Okay. Now I'm going to go ahead. I'm going to do the bottom left, bottom right, and say angle, 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 angle. So the ones, the little one loop there, the little angle type sign there, shows that this piece and this piece, okay, are the same angle. Okay, if that's 50 degrees, that'll be 50 degrees or whatever it is. And by showing that it's got a little double angle there, okay, a little double rainbow there, all the way, okay, and vertex B and vertex N have the same angle measurement there, okay, and not just the same angle measurement, but if the side in between those angles are the same measurement too. And you can see that by the little mark here, the little mark that shows a little single mark there, okay? So I can say with confidence that triangle ABC is congruent to triangle MNO. Okay. I'll leave this up for about 20 more seconds, 30 seconds, and then we'll go back to watching the video, review this, and talk about the same kind of thing, right? Remember, if those pieces are the same and the claim is made that they're congruent, that means all the other pieces are the same too. Okay, kind of one of the purposes that we do this a lot of times is to find missing information about one of the triangles. Okay, and the reason why the other pieces are the same is because the idea that corresponding parts of congruent triangles are congruent. Okay. Okay. Let's go ahead and stop that. I'm going to mute myself and let's go back to the video.
This tells us that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. And again, this order is important. So if angle A is congruent to angle D, and angle F is congruent to angle C, and then if side AC is congruent to side DF, these two triangles will be congruent. Notice how we have an angle, an included side, and an angle in both triangles. And the last postulate we'll look at is the angle-angle side postulate, or the AAS postulate.
Alrighty. So you guys can assume the same thing, right? The sides. Let's go back to the song, right? Oh, let me make sure I'm presenting side, angle, angle, side. And it's almost like I read the future, right? I knew the exact order he was going to do. Okay. Now, obviously, I've seen this video. I scrubbed through it to make sure it covered the right things. But before I even saw the video, as soon as he brought up triangle congruence, in my head, there's just this general order that we've always kind of done that I was taught, and it seems to be a good logical way to teach it. Maybe just rolls off the tongue good, but side, angle, 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 side. Yeah, love it. Okay, that is a show closer right there. If you guys are ever in a band or a musical group, you guys should end your should do your what do you call it, your encore. Give me a shout out. So, all right, angle, side. So angle, side, just you can hopefully imagine at this point, you got two triangles. You got two angles that are the same. And then something about a side piece is the same, okay? So let's do this triangle. And let's do this triangle. Let's call this ABC. Okay, M and O. And angle, side. So I'm going to go ahead and say A and N are the same. Let's label B and N to be the same. So once again, you got two angles, and the angles are next to each other. Okay, so A and B, M and N. Now here's the thing with triangles. Okay, any two angles you pick are going to be next to each other. There's no way you can have two angles out of three and have some sort of weird thing with like gaps in between it. Like there's a gap going this way, but not a gap that way. So however you see it, okay, you can have a side piece on here or a side piece on here, right? You can either have these ones or you can have those ones, okay? It can either be like the side angle or the angle side, because you can read it different ways, actually. You can actually read it going left and right, right? All of these could have went any direction, right? Those two, angle, side, angle, side, angle. If it went backwards, it's still angle, side, angle, right? Anyway, look at this. You've got three sides, okay? This just says you have two sides with an angle in the middle. It doesn't really matter if you go this way or that way, as long as it follows that order, okay? As long as they're corresponding parts, okay? Now, this one, okay, it's angle, side, angle. So that side is not in the middle, okay? That side is on the side. So I'm just going to kind of show you right here that it's, you know, it might look something like that. If this piece over here was the same instead, it would be the same thing, okay? So once again, I can make this claim now because I have this information that this triangle is congruent to that triangle, and I say that by writing this out like this. Triangle ABC, triangle MNO. Now, something to kind of keep in mind, well, the problems you're going to see on this in this chapter or in this section, a lot of times they don't give you pretty triangles like this. They make them sort of like sideways and upside down, and they try to do little weird tricks and stuff with you. So what I recommend doing, and I'll show you the practice problems when we get there, is actually just redraw out your triangles and try to label them. Well, do your best, okay, to keep it the same labeling, because if not, then you're going to get it wrong. It's like writing the wrong numbers down. So when you draw these pictures out, just know on the actual problems, Okay, understand it like this, but when you see it like in the real world, or you see it at least in the problems for this chapter, it's not always going to be laid out like this. They might be all sideways and upside down and weird stuff like that. Okay. All right. I believe you've had enough time to copy this down. If you guys are having trouble with your internet or I'm going too fast, I'm trying to give you guys plenty of time, but if I am going too fast and not clear enough, I will post these notes online when we finish, and I will share this video, guys, as well. I will share it sometime after we finish too. Okay, let's see what else they have to say. Okay.
This tells us that if two angles and a not included side of a triangle are congruent to two sides and the corresponding not included side of another triangle, then the two triangles are congruent. So if we know this angle is congruent to this angle is congruent to this angle, and let's say these two sides are congruent, we know these triangles will be congruent. And this is really just a variation of the angle-side-angle postulate, because if we know that two angles of two triangles are congruent, since we know the sum of the interior angles is equal to 180 degrees, then the third angle of the triangles would also have to be congruent. So looking at the right side of these two triangles, we have angle-side-angle and angle-side-angle. But again, we can just use angle-angle-side if we wish. Now we're going to take a look at several diagrams in the next video on determining if two triangles are congruent, but let's just get a feel of where we're headed. If we want to know if these two triangles are congruent, we want to see if they can satisfy one of the previous four postulates from the given information. So looking at this diagram here, notice we have two parallel segments that are also congruent. Well, if these two segments are parallel and they're cut by transversal EC and transversal BD, we know that alternate interior angles would be congruent. So angle E would be congruent to angle C, and angle D would be congruent to angle B, again by alternate interior angles. So now if we take a look at what we have here, notice we have two angles that are congruent as well as an included side. So this satisfies the angle. So by the angle-side-angle postulate, we know that these two triangles are congruent. So by angle-side-angle,
okay, so I'm going to kind of pause it there because he's kind of going a little bit extra stuff. He's doing more of the proof type style, which actually is really neat and it's really cool. I just don't want you guys getting too many things in your head right now. So let's switch over to the other video. Okay, the other video has more practice problems, and we'll kind of address things there. Okay.
if two triangles are congruent. The goals are to review the ways to prove two triangles are congruent and then identify congruent triangles. Two triangles are congruent if and only if corresponding angles and sides are congruent, as we see marked here. It's important that when we identify congruent triangles, that the vertices are listed in corresponding order. So if we identify this triangle as triangle ABC, it would be congruent to triangle MNO because vertex A corresponds to vertex M, vertex B corresponds to vertex N, and vertex C corresponds to vertex O. When referring to corresponding parts of congruent triangles, it is called corresponding parts of congruent triangles are congruent, or CPC-TC. Now remember from the previous video, there are four postulates that can be used to verify two triangles congruent. We have the side-side-side postulate, side-angle-side postulate, angle-side-angle postulate, and angle-angle-side postulate.
So he's about to talk about SSA and AAA. Just so you guys know, just because there's some congruent parts to triangles and different shapes and stuff does not mean that they're necessarily both the same. Okay. With the angle, you should mention that you can have two different size triangles, right? One's a small, one's a large triangle that have the same shape, right? You got like a small triangle and a big triangle. They can actually have the same angle measurements, but just have different size side lengths, okay? And so with two triangles with angle, 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 they could be similar, but it doesn't mean that they are the same. Same thing with the SSA, with the side angle. There's a very special way to look at it. I don't want to go into too much detail right now and try to confuse you guys, but side angle is one of those things where there are all times they might look the same and a lot of other stuff with it, but it's not enough evidence. There's a special case where you can have side angle and they're not the same. Okay, it has to do with a triangle looking like this versus being like either acute or being obtuse, and it has to do with a few other things kind of happening. So a lot of times if you have two sides in an angle, like side angle, they'll be the same eventually just by other information you can kind of put together, but side angle is not reason enough to say that two triangles are congruent. Okay, because there are times where you can have side angle and they're actually two different triangles where they just so happen to have two side lengths the same with an angle on the outside the same, but they can actually be drawn and labeled and the size can actually be different. Okay. All right.
And notice that side angle and angle cannot be used to determine congruent triangles. So let's take a look at our examples. Here we're given a sketch and we want to determine if the triangles are congruent, and if they are, give the reason and then state a congruence statement. So notice that we're given that segment AB is congruent to segment DE, and they're also parallel. So if these two segments are parallel, notice that BD and AE would be transversals. And therefore we know that the alternate interior angles would have to be congruent. So angle A is congruent to angle E, and angle B is congruent to angle D. So looking at the information that we have, notice we have angle side angle and angle side angle in both of these triangles, and therefore by angle side angle, triangle ABC would be congruent to the triangle on the right. And again, we need to make sure we list these vertices in the corresponding order. So notice that angle A corresponds to angle E.
Real quick, I'm going to kind of fast forward a little bit because what he's doing right now is awesome and it's really good stuff. It's just your practice problems and your tests and stuff that you'll have on this stuff will not look like what he's doing with the transversals and things like that. Your practice problems and your tests will not have that stuff. You'll have different kind of labels. So I'm going to go ahead and skip the video a little bit until we get to the point where it looks like what you will be assessed on. So it's really cool stuff he's doing, but I'm not going to be testing you guys at that level where you got to mix transversals with triangle congruence. But as you can see, there's a lot of like crossover from other topics that can kind of be applied to this as well. Okay. So give me a moment. I'm going to fast forward until we get to the point where he actually discusses the kind of questions you're going to see. Okay.
Same question, different diagram. Notice the only information we're given here is segment AB is congruent to segment BC, and segment AE is congruent to segment CD. Now these two intersecting segments do form vertical angles, so we could conclude that angle ABE is congruent to angle CBD, but notice we have side angle. Side angle, or angle side does not fit one of the four postulates, and therefore we cannot conclude that these are congruent triangles. So by the given information, we cannot conclude that these are congruent triangles.
So right there was a great example where it was side angle. And remember, side angle was the ones we talked about where it's not necessarily congruent. It might be, but we just don't have the information. So don't think that every single problem is going to be congruent. It just, just check the boxes. Okay, it's good. It's good. It's good. There's going to be examples that might be difficult to tell what they are, and you have to have the evidence. You got to have the proof. It's either side, 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 angle, angle, or angle, angle, side. Okay, it's got to be one of those four. In fact, before we finish these notes, I'll give one little quick cheat, little cheat thing. Put on your notes. Just put SSS, side, 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 angle, side, SAS, angle, side, angle, ASA, or angle, angle, side, AAS. Okay, so we'll write those down as like a little cheat sheet. Okay, hopefully it makes sense to you guys now about those little four things. But sometimes they might look the same, but if you don't have the evidence, then it doesn't really matter what they look like if you don't have the evidence for it. Okay, it has to be one of those four things.
Let's go and take a look at one more example. Notice we're given two pairs.
Just for the sake of time, you guys won't, from what I've gone through, everything on your material, you're not going to see something like that. It's still good stuff, and you guys have links to those videos if you guys want to watch that stuff and learn more about the more advanced stuff or different things that'll look like that's not in our work. You just want to get more knowledge. Feel free to go through that and check it out. It's pretty cool stuff, but it's a little bit different than what I wanted to show you guys. Okay. All right. So let's summarize those four things, and then I'm going to show you some practice problems. Okay. So we're going to go ahead, and I'm going to go back to the side of my notes here. Let me show you guys where we're at. Let's do another review. Okay. So what do we have here, right? Notes on congruent triangles, right? That little squiggle mark is a symbol for being similar, which means the same looking, like they look the same. Okay, they have the same angles and stuff. The equal sign means they have the same area. Okay, that the same lengths. That's what equal means. You put those together, it's the same shape and the same size. It means they're congruent. Okay. Side, side, side. All three sides are the same in the same order. Side, angle, side. There's two sides of the same, and the angle between them is the same. Okay, they're in the same order. Angle, side, angle. Right, you got two angles that are the same in the same order with a line in the middle that are the same length. And lastly, two angles are the same in the same order with the outside side that looks the same. Okay. If it follows those rules, okay, that means the rest of the triangles are the same. That means the whole things are exactly the same. They're just like cookie cutter, the same. So I'm going to make one quick little note here, and I'm going to say, okay, SSS, side, 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 SAS, side, angle, side, angle, side, angle, ASA, and then AAS, right? The last one is angle, side, or angle, angle, side. So it has to be one of these in order to be legit, okay? Pretty fun, pretty cool, okay? Let's get it. Pretty awesome, okay? It's got to be one of those four. Okay. So let's take a look at what your questions will actually kind of look like for this chapter. I'm going to kind of just show you guys a few here. Let's do this one. All right. So I'll just do two examples for you guys, and then we'll call it. That's kind of like mainly what we're looking at here. Okay. All right, so this first example looks something like, let's do it like this. All right, you know what? So it looks kind of like this parallelogram with a line through the middle. Let me make sure you guys see it. Yeah. Okay. Looks kind of like this. And in the end, so what's going to happen, the reason why I kind of stopped the video is because the video examples were kind of stripped down and it required you to do a lot of little prep and stuff. The way this one's set up, however, the way the work on your practice is set up is they give you a lot of the stuff. right? Parallelogram, the top and the bottom are the same, and the two sides are the same. Okay. And then what happens is the opposite angles are the same. Now they're going to draw it like this. And I'm going to explain this in a moment, how there's different ways to say congruence. There's different ways to show that with the angles. And they showed it here in your practice problems. Okay. So I'm kind of glad that we got an opportunity to discuss this. So you know how in the notes I was showing you guys, and even on the videos, they were showing you guys how like the angles like this, how like A and M are the same because they have like the one little mark, and then B and N are the same because they have the double marks. Okay. A different way to show the same exact thing is like this. Okay. Is to draw the little arc there and then make like a little mark through it. Okay. The 1 and the 1 show that those are the same. The 2 marks and the 2 marks here, you see how it's 2 and 2? That's just a different way to say the same thing. And so you're going to see this throughout the work and the practice and different stuff. My personal preference, like the notes, my personal preference is to show this. However, this is one of those things in math that they have not fully agreed upon, I guess, that how to show that. Okay. The best way I can describe the inconsistency or the differences is like the number 2, for example. You know the number 2, you can write it like that, or you can write it like this. It's like, well, that looks more like a Z. It's like, well, yeah, but it's also a 2. You know, so you can put the number 1 like this, the number 1 like that. It's like how you're writing slightly different thing, but it means the same exact thing. And when I communicate like this, there's no issues. Like if I wrote this for 2 or that for 2, I'm pretty sure you guys could tell what I wrote. If I wrote this for 1 or that for 1, I'm pretty sure you guys would know what I wrote. Okay. So it's kind of the same thing with these little symbols and marks. Okay. Sometimes people write it like this, or books or diagrams show it like this. And sometimes they show it with the those little bubble type drawings. Okay. I kind of prefer to write it like this, but this is also a standard way to write it as well. Okay, so what do we have here? If you guys remember what I was talking about, what I was talking about at the beginning was to actually, they're going to give you drawings, and I recommend, and they might be all twisted up, but I recommend just redrawing these things. Okay, so I see this, and I'm thinking right now, I've got this triangle like this, DBC. I like the way that looks. Okay, so I'm going to kind of draw this out like so. Is it going to be the same size as this one? No, but I'm just going to draw it like a smaller version of it, and I'm going to label it the exact way that they have it here. Okay, so it's got it labeled like this. Yeah. Now this one here, I'm going to take this and I'm going to look at it upside down. I know it's going to be weird, but I'm going to turn it upside down and look at it like this. Okay, so it goes B, A, D. Kind of like the word bad. I know it's written upside down, but this is a B, that's an A, and that's a D. Okay, so it looks, hang on. The right side goes up and then along over. So the right side goes up and then it goes over. So right now, these actually look the same, right? Now that I kind of redrew it, and then BAD. So left, right, up. So it goes BAD. Okay. Once again, the letter D is on top. A is the bottom right. B is the bottom left. So wait a minute. A is the right side. Ooh. Okay. All right. One more time. Let me double check to make sure I'm doing everything correct. A is the right side. B is the left side. D is on top. A is the right side. B is the left side. D is on top. So A has a double mark. B has the single mark. Vertex point D has the triple mark. A to B has a single slash here. A to D has a double there. Do those look the same? They look absolutely the same to me. So if you were to be given the choice to say what that is, okay, okay, it's obvious right here. You have angle, side, angle, angle, side, angle. Okay. You have side, angle, side. You got side, angle, side. Now, something that's not written on here, I'm going to use a different color for this. Okay. Something that's not written on here. Okay. This piece here is equal to itself, right? From D to B is the same on both of those. So I'm going to write that in, even though they didn't give it to us. It's obvious that angle, side, angle, everything's the same. Angle, side, angle, right? Everything's the same. All these different ways to say it, but also the fact that this side is shared between both triangles. Okay, you see how this piece and that piece are not really on the same triangle. They're like on the same drawing, but they're on different sides. This is actually the same piece. Okay, it's cool stuff. All right, so what's going to happen for you guys is they're going to say something like this. Okay, they're going to have you fill in the blank. Okay, they're going to tell you, they're going to give you a picture like this, and they're going to tell you, hey, these two triangles are congruent. They're going to, you know, this is like one style of question they can ask, is they're going to tell you they're congruent. They're going to give you a picture like this. Okay, but here's the thing. They're going to give you different options with the letters all mixed up. So by me showing you guys this little prep of like rewriting it and drawing it and getting like nice and pretty. Okay, remember how I was showing you every single time, like the rotation of how you do the letters in order? It's super important. Okay, this is kind of where it shows up. So now that I know that it looks like this, and I'm going to look at ABD is this side here, ABD. So you see how it goes from, let me see if I can get, okay. Yeah, this is fun. So you see how it goes from A to B to D. That's how they labeled it. So I'm going to label this triangle from C to D to B. C, D, B. So triangle. So that says that the vertex point at A in its congruent triangle is the same as the vertex point C. Okay? And that the vertex point B in this congruent triangle would be vertex point D. And then last but not least, vertex point letter D is the same as vertex point B for this triangle. Okay, so this takes a little bit of prep work and a little bit of, I would say write this stuff out. Don't try to do it in your heads. Okay, even I, as a math teacher with a lot of experience in this stuff, have to write this stuff out just to kind of make sure that I'm correct and I'm not just making some weird assumptions. Okay. All right. Any major questions right now, or I'm going to show you guys one more thing before I let you guys go. Any major questions? Going once, going twice.
No,
all right.
sir.
Okay, so let's go to example 2. All right, so let's call this example 2, and I'll show you guys one more example. Or I'll show you guys this example, and then we will be good today. All right, so you notice I put the letter 2, the number 2 like that. If I wrote it like that, or I wrote it like the other way, I'm pretty sure you guys understand what it means. Okay. Okay, so this one's going to have a little bit of algebra in it, and this one's actually not even going to be a triangle. Okay, but it's still on the same topic as what we've done before. Okay. Let's see here. So what's going to happen is they're going to give you a question. Let's see here. Okay, this is perfect. It's going to look maybe something similar to this. So you got some sort of figure here, and then they draw the figure like upside down and sideways and all weird and stuff. Okay. And what they tell you is something like this. They say A, B, C, D. And let's do W, X, Y, Z. and they say polygon. So Jared, I know your mic's working and stuff. Jared, do you know what a polygon is?
Yes, sir.
You said, I'm sorry, you were cutting out. You said yes or no?
Yes, sir.
What's a polygon?
Okay, I'm pretty. Is it 5? It has 5 sides?
Nope.
Nope. Am I wrong? Okay.
So a polygon, Jared, you ready for this? This is what Mrs. Hill taught me, and I still remember it to this day. And Miss G, I'm pretty sure she's probably heard this before. A polygon is a dead parrot. Have you heard that before?
No, sir.
Do you know what a common name for a parrot is? Polly wants a cracker.
Polygon.
Yes, sir.
Polygon, a dead parrot. Polly's gone. Okay, it's a really dumb, bad geometry joke. I'm sorry if anyone's got a bird that passed away, but polygon. The joke, Jared, is that it's a dead parrot. Polygon. 2 words. All right, I'll stop there.
Yes, sir.
Okay, so a polygon. Okay, polygon by definition is just a shape, like an enclosed shape with like straight lines, right? And it can be a triangle, a square, anything with lines that creates a shape, like all this right here. Okay, besides the circles. Okay, but a polygon is a shape. Okay, a triangle, a square, a pentagon, anything like that is considered a polygon. Okay, what you were thinking of I think you're thinking of a 4-sided shape would be a quadrilateral. A 5-sided shape would be a pentagon. Okay, and then beyond that it keeps going, gone. Okay, heptagon, hexagon, all that stuff. All right, so we're telling you right now that polygon ABCD is congruent to polygon WXYZ. Okay, and then they're saying, I'm going to give you some more information. I'm going to say this piece up. Oh, wait. Oh, I screwed this way up. I sincerely, utterly apologize. I screwed this up. I'm trying to recreate the drawing, and I totally made an incorrect looking drawing. Because that would be very difficult to explain because it would be really weird looking. I'm so sorry. Did not mean to cause any confusion. Okay, I sincerely apologize. I'll give you guys a moment to correct that. I'm so sorry. Okay, did not mean to cause any sort of confusion with that drawing. Okay, it should be angled like that. All right. So I'll give you guys about 30 seconds to make that correction before I tackle this problem. So they give you that information, and then they're going to ask you a question. Okay, so what they're going to ask you is to find these 3 pieces of information. They want you to find what x equals. They want you to find what the piece AB equals and the piece WX equals. Now, they didn't give you a lot of information, okay, which at first can be kind of daunting. At first, it can be kind of frustrating that they didn't give you much information. However, they gave you enough information that they need, that you need. Okay, and I actually look at this and I actually appreciate it because they didn't give you a lot of extra stuff that you got to filter out and kind of like ignore. Okay, which they will do sometimes later. They'll try to give you extra stuff that you don't need, and you've got to understand what you do need and what you don't need. Get rid of what you don't need and use what you do need to focus on what to get the answer. So in this problem, okay, the fact that they said that these are congruent, okay, and look at what we have. You see how we have. I'm going to go ahead and mark the heck out of this thing, okay? You see what they gave us? They gave us piece AB, okay? You see from line A to B, it equals 5x minus 7. So from A to B, that equals 5x minus 7. Now, what's so important about this information right here about 5x minus 7? Okay, well, you see here how AB is the first letters. Okay, since AB is the first letters and we know what AB is, look at over here. You see how it says WX? Well, look what they gave us right here, WX. You see that's the first two letters, So if these are congruent, okay, if I was to write this out as like a mathematical statement, and I said AB, CD is congruent to WX, Y, Y, and Z. So, and this is what they gave us in words. This would be like the math statement. A, B, C, D is congruent to W, X, Y, Z. So much easier and faster than saying this whole thing, right? But you notice, hopefully you notice, since they gave us A, B, that means those similar pieces, you see how it's like the first two? It's like the first two. Those are the same, okay? So they gave us W to X. They gave us that statement. Okay, AB, WX. So they told us with this one that this line segment is 3x plus 5. So that means that this length and that length are the same. Okay, because the whole figure is congruent. Those pieces are in the same positions if I was to rotate that around. Okay, so that means that AB we know to be congruent to WX. Okay, or I should actually, we know it's congruent, which means they have the same length, that they're actually equal in length. Okay, so I'm going to go ahead and say 5x minus 7 is equal to 3x plus 5. Whoops, let me go ahead and slide this down a little bit. Whew. Okay, a lot of prep work, but here we go. Let's solve this using some algebra. So I'm going to go ahead and subtract 3x from both sides. I'm going to add 7 to both sides. And then last but not least, let's go ahead and finish this off by dividing 2 to both sides. Okay, just using those techniques from algebra. If you guys need more assistance with algebra type processes, let me know. We can kind of practice that, or I can show you some more resources to help with that during tutoring sessions, okay? So I get x equals to 6. So that answered one of the 3 parts of the question. Okay. Cool. So I got one piece of information. Well, they want us to find AB. We know that AB is 5 times x, which is 6, and then subtract 7. So AB, we know, is 5x minus 7. However, x equals to 6. Therefore, we get 23. Now, I'm going to show you a way to check your work to make sure everything works out. I'm going to assume that this is also going to be 23. Why? Because we set them equal to each other, because it said it's congruent. It says the parts are the same. There's all these things that are, all these signs and flags that say they're the same. Okay? But a general rule, a good mathematical practice to do is just always kind of check your work. So I'm going to go ahead and say that WX is equal to 3x plus 5. Because doing this, what if I made a mistake here? Like right now, I feel confident that this is correct. Okay, I feel 100% confident this is correct. However, if I do this and it doesn't work out, I've got to check this. And then if that doesn't work out, I've got to check that. So it's one of those ways to just, that doesn't take too long to check your work. So when teachers say to check your work, that's what they're saying. Okay, they're saying, does everything kind of make sense on your problem? And sure enough, I get 23. So that confirms that that's equal to that, right? This number made those two equal. Therefore, I feel very confident that I proved this to be correct. Because if that was 7, those wouldn't be equal, right? If that was 5, I'm assuming those won't be equal. Any other number, those won't be equal. Cool. So one more time. What I did was they gave us this information. Okay. They told us the order of which it works like this. Okay. Now here's the thing. They're not going to do any weird funny business, at least not yet, and give you a lot of stuff you got to filter out. So it's kind of best to kind of hopefully see it like this. So just kind of whatever they give you, essentially your first initial reaction is to assume that they're the same. Okay. However, you should always kind of double check and go through the steps to make sure that it actually is. All right. So I'm going to stop the video. That's your notes. And then any questions you guys have, feel free to stay back and ask those questions. If you have any other stuff you want to kind of go over or discuss, we're here. Okay. So I'm going to hit the stop recording.